Manipulating Data, Part 1 of 2. In this nugget, we undertake a formal consideration of data manipulation language, or DML. Of course, the select statement with which we've been involved throughout every nugget of this series still applies because it is indeed a DML statement. We're going to split the DML statements into two nuggets. This first one, we're going to learn how to insert new rows into tables as well as make changes to existing row data. Specifically, by the end of this nugget, you'll understand the basics of using insert and update in your structured query language. Good stuff in this nugget. Let's put our thinking caps on and get to work. We're going to begin this lesson with a brief review of the SQL structured query language command classifications. You'll recall, because we've used these acronyms a lot, the two main classifications are data definition language, also called DDL statements, and data manipulation language, DML statements. You'll also recall, by way of review, that the chief distinction between DDL and DML is that your DDL statements work at the object level, bringing objects into existence. Those objects could be tables, indexes, sequences, and so forth. Of course, we use the create DDL statement for that. We also can make structural changes to those instantiated objects with alter. We can remove objects with drop. And we also looked at rename and truncate, which allow us to change the name of objects or remove all rows from a table respectively. At this point, you should be really comfortable with all of these DDL statements. In this nugget and the next one, we're going to become familiar with the four primary data manipulation language statements, which, to tag on to our discussion of DDL, the distinction with these is that these operate on already existing objects. DDL brings the object into existence and DML fills in the blanks. Or as far as a table is concerned, DDL brings a table into view, the DML can populate that table with data. The four main ones, as we know, are select, insert, update, and delete. Select is actually a DML statement. If you're fairly new to SQL, having used select and knowing that it can bring back in a read fashion rows from one or more joined tables, you may be at a loss somewhat to think of select as a command that's used to manipulate data, but it actually is. We can select into objects. As a matter of fact, in this nugget, I'm going to show you how we can use subqueries, for instance, to insert data into tables that comes to us via a select statement. So absolutely, select is a DML statement. Two commands that are out of scope for these two nuggets, but we've briefly talked about and touched on earlier, are call and explain plan. Call is what we use to invoke stored procedures, our PLSQL code in other words. Explain plan, as you know, enables us to see the query execution plan that Oracle uses when it satisfies query results. This can be excellent for troubleshooting and also performance tuning in Oracle database. Now, the lion's share of our work, not only for the exam, but your work as a SQL admin, are going to be with DDL and DML. However, we're also going to be covering DCL and TCL. That's quite a few TLAs, right? TLA is a military term for three-letter acronym. DCL stands for Data Control Language, and the two main DCL statements in the structured query language are grant and revoke, and we use these to give and remove system and or object privileges. We're going to be covering DCL in a separate nugget. In the next nugget, actually, after this one, we're going to learn how to use the TCL statements. This is transaction control language statements, and these deal with the ability to have more granular control as a database administrator over database transactions. The main ones are commit, which makes your changes permanent in the database, rollback, which does the exact opposite, throws away your changes, save point, which enables you to gradually work through a transaction batch and be able to selectively roll back to certain points in that transaction, and set transaction that enables us to set properties for a session. More on that in the next nugget, of course. Without further ado, let's get into DML here. The first of the two DML statements on board for this nugget is insert. We use the insert SQL statement to add a new row to a table. It's as simple as that. We know how to use create table to design tables. We've talked a little bit about selecting the appropriate data types for your columns, applying constraints to those columns to eliminate, hopefully, the possibility of user error introducing incorrect data into your table. And we also touched on just a little bit of normalization, of separating your data as atomically as possible across multiple related tables. All that's really good and all that's DDL for us. We then use insert to actually introduce data row by row into a table. So an insert is going to actually instantiate a new row altogether. I don't mean to belabor this point. It's actually not as complicated as I'm making it sound. Let's take a look at the syntax. To use insert, you specify insert, obviously, into, and then the destination table name. So in this sample, we're inserting into a table called products. Now, the next part here that I'm pointing to, this parenthesized list, is officially optional, but I'm going to make a good argument that in most cases, you'll want to include it. And what are you including? This references the columns in the products table that we're adding data to. And it makes sense if we're adding a new row, we want to cover all of the columns in that table. So officially, you don't have to specify the column list. As you see in my second example, I'm typing insert into products and then immediately jumping to the required clause, which is called values. So you definitely have a more explicit approach here. Explicit in terms of there's absolutely no ambiguity on Oracle's part in terms of lining up the prod ID, prod name, and price column names with the values that we're adding in that row, in this case product ID 110, prod name foobar, and price 99.99. As long as you're covering all of the columns in the destination table, though, officially, you can, as I said, ignore the column list and go right into values. And the way this works is this is a comma-separated list. Doesn't matter if you have no spaces or 100 spaces in there, as long as you have a simple comma separating each data element. Numeric data doesn't need quotes, but character data and dates do need to be enclosed in single quotes. That's a common beginner's mistake. For instance, if I in the second statement put barfoo without single quotes, I would get an ORA error in response. By contrast, if I enclosed 129.99 with quotes, I may get an error if I'm binding the number or float data types to that column. Actually, Oracle may indeed perform an implicit conversion there, seeing, well, this looks like a number. It seems to be coming in as a string based on these single quotes. Bottom line, as I said, friends, we want to be as explicit as possible here. Make sure to follow the rules. And that helps not only Oracle, but also, I submit, helps you in your job because you're being more explicit with your code, with your scripts, and when you do code reviews with your boss, with your colleagues, they won't be able to find fault in your code and accuse you of being cryptic. Finally, nulls should also be made explicit. As you know, when you build a table, probably the most common constraint added to a column is nullability. It's either going to allow nulls or you specify the not null constraint, and that tells Oracle you must, when you do an insert, put some data there for that particular column. So for instance, let's say in the products table, prod ID being a key field we can surmise certainly would not be null. Prod name, let's say we have to have that, that's not null, but let's say in the table definition we did not apply the not null constraint to price. We could do an insert where I'll just write this in, where we say insert prod ID 130, the product name I'll just call it P1 for grins, comma, and then we can just say null in either upper or lower case. That keeps the place here. In other words, Oracle sees that there are 3 columns in the destination products table. It sees that we're supplying 3 elements, and it also sees that in place of the third element, it's going to insert an allowed null value. You see what I'm saying? Now, if you leave null off and just submit the 2 elements, you may be okay, but again, you run the risk of not being explicit enough with Oracle. And you'll find on your SQL Fundamentals exam, Oracle the company, is very explicit on how they present their code. So you should do the same thing. Now let's get into what I call insert funny business. These are perhaps some slightly lesser used cases, but important, really crucial for you to understand, not only for your certification success, but also for your real world success as Oracle DBAs. I'm going to separate these so you know that they are in fact 2 separate insert statements. And just take a look at the first one and tell me if you see anything that's a little bit out of the ordinary. Well, we'll take it piece by piece. Insert into test table, that's correct, right? Certainly would pass muster. We're also, in this case, being explicit and providing a column list for that table. It looks like test table has 5 columns: ID, date 1, date 2, text, and text 2. No complaint there, right? Values is in fact the next clause, so the funny business, so to speak, must be in the values clause itself. Now, first of all, let's make sure that we have parallelism. We have 5 columns to be inserted. Let's see that there's 5 values to go in. 1, 2, 3, 4, and 5. Yep, so far so good. The first thing that's a little bit different is you'll notice here the second entry, that is the date 1 data, we're calling a function. So know that we can in fact use certain functions in our insert statements. This harkens back to when we learned about functions earlier in the course, and I told you the chief advantage of the function is its great flexibility. And I mentioned that by contrast to a stored procedure, which cannot be used in expressions or inserts or creates, functions can. So function is really, I would say, a gymnastic code module, if you don't mind that metaphor. Sysdate, of course, is going to pull the computer's current date and apply that to this particular row, row 245. The next thing that's a little bit different is that we're taking the toDate function and we're inserting a date format and formatting it a particular way. As you know, Oracle's default date format is a little bit cryptic. You may have a business need in your table to store dates in a way other than Oracle expects. So in this case, the data entry clerk would put in March 16th, 1990, and the insert statement behind the scenes in your line of business application would invoke the toDate function to make sure that what comes in as a string comes out and into the table as an honest-to-goodness Oracle date data type. In position 4, text, we're passing in null. I hope that we don't have not null attached to this column, or we may have some problems, right? And finally, foobar is just fine with text too. So this example is just to show you some of the flexibility we have inherent in the Oracle insert statement. The second example gives us a run of using select, an embedded query, to retrieve rows that will then be copied into a destination table. So in this case, we're inserting into the products table. Prod ID, name, and list price are the columns in the products table. And when you embed a subquery into an insert statement, there's no values statement here at all. You'll note that we go directly into the select statement. And if you want to put that in parentheses, that's fine for clarity. But you see that I'm selecting ID, prod name, and price from the prod archive table where ID is between 100 and 500. So this query is going to run first and retrieve those rows. And then those data elements, of which there are, remember parallelism, 3, will be inserted into the products table. Now a couple points to note here. Note that the column names do not have to match. However, the data types, as you would expect, I hope, absolutely have to match. So whatever the numeric or character data types are in this prod archive table need to be mirrored in our destination products table. But because the name is simply a label, I hope it makes sense to you that that really is immaterial whether the names match. Frankly, it would be a good idea to have them line up as closely as possible just to avoid human error so that you, your boss, your colleagues know what's what. But they don't have to match, only in data type. The second DML statement under consideration in this nugget is update. Now, update is used to modify existing rows in a table. So if we want to string some SQL along in its proper order, we have the create DDL statement, then we have to have at least one insert to add at least one row, and then we would use update to make changes to those rows, one or more rows that were inserted using insert. Let's get right into the syntax here. It's actually pretty straightforward. Not too much variation here. Basically, you first, and this is step 0, you have to ask yourself, what do I want to change? In this first example, I'm just going to set the stage. Let's imagine that an employee named Susan Harder got married, and her name is now Susan Warner. This is a personal example. My wife and I are celebrating our 9th wedding anniversary in 2 days, and her last name 9 years ago was Harder, and it's been Warner ever since. At any rate, back to the regularly scheduled programming. We as a DBA have been asked, let's say, by Susan Harder Warner, can you please change my last name in our database? Yes, we certainly can. We can do that via an update statement. So we're going to update a target table, in this case emp, and then we use 2 keywords that always go along with update. just hand in glove, peanut butter and jelly, whatever you want to say. We set a field to a particular value, in this case the last name column from the emp table, where, and then where determines which row or rows will be affected by that change. In this case, where last name equals Harder. Now this is kind of a scary query because of course you're probably thinking logically, what if there's more than one Harder in the table? It might be better actually to filter your where on something like employee ID and use her ID value, which we know is guaranteed unique. But just bear with me. I hope you have the general flow. After executing this query, Harder's last name will become Warner, period. And if you have referential integrity, cascade rules applied with joined tables, this change will be pushed to all related tables. That's actually a point that's worth a little bit more investigation. When we create, let's say, a one-to-many relationship, maybe we have a projects table that includes data from this table here. Well, we may want any reports and stuff that are built off the second related table to reflect accurately. That is, if we have Susan Harder's name all over this related table and related objects from that table, and we change her last name to Warner, well, the emp table is now current, but any related tables aren't. So you want to consider rules for cascade update when it comes to related tables. Next example, this is one of those scary things you want to be really careful of. I mentioned that update, set, and where are just, finger and glove partners in their action. If you leave off the where statement, you're going to update all the rows in the table. So this statement, update emp set department ID equals 500, soon as that goes, you're going to find that every employee in that table will be associated with department ID 500. So unless that's not what you want, be very, very careful. Yes, of course, Oracle has technologies to recover from that kind of problem. In point of fact, we're doing a nugget on flashback query later in the course. But best practice is you don't want to make this kind of rookie error to begin with. This third example shows where we can set or change or update, whatever term you want to use, the values of more than one column. All you do is simply list the changes in a comma-separated fashion. That is to say, update emp, set task ID equals 50, comma, salary equals 100,000, where emp ID equals 8675309. So in this case, we'll only be affecting Jenny's account. If you don't mind that reference, again, I know I've already used it once. I'm getting low on material here, friends. But in this case, certainly whatever his or her task ID was prior to this update will then reflect, from now on, reflect 50. His or her salary will reflect 100,000. In this demonstration, we'll work with the insert and update statements in Oracle 11g. Here we are logged into Oracle database as the HR user, nothing special there, and we're in the SQL Developer tool. To get right into it, let's look at line 4, our first example of using the insert statement. Here we're inserting a new row into the HR.departments table, and you notice that I'm using the formal syntax in which we provide the column names one after the other in the proper order, and then the values clause to add that data in. Now before we run the insert, I think it would be instructive for us to look at the structure of the departments table once again. If we were working from an SQL command prompt, then certainly we can query the data dictionary or use the describe command. We'll actually work with the data dictionary in an upcoming nugget. For now, since we have the convenience of Oracle SQL Developer, I'll simply double left click the table in the tables list to get its full metadata run here. You notice that by expanding a table in SQL Developer, we can see those column names for reference. Of course, we can also visit the Columns tab to get the same information. This gives us more information, of course, including nullability data, data type, comments, column IDs, etc. Of course, in understanding tables, we also should check out constraints to see what's going on with regard to those. And in this case, we've seen this before. The departments table uses the primary key constraint on department ID. We have a check constraint such that department name is absolutely not null. That's just simply brought in from the not null clause. And then we have two foreign key constraints for mapped columns from the location and employees tables respectively. Alrighty then, so given that background information, we can craft this statement. And actually, let me run a select splat from departments just so we can verify that right now the department ID values run from 10 all the way to 270. Now since there already is a department ID 210, this isn't going to work, so I'm glad I did that. Let's make this new row 280. We'll call the department name maintenance. We'll assign the manager ID of 204, which, remember the foreign key constraint, referential integrity says that unless there is in fact a manager with an employee ID of 204, this insert just isn't going to work. Same thing with location. One of the great benefits of related tables, what's called referential integrity. So we'll select this. One row inserted. Good deal. So now we can verify this by running a select star from departments where department ID equals, and then what did we put in? Let me check that again. 280. Run that query, and there we go. We have our new row. Let's try some variations here and see what happens. On line 13, we're inserting another row into departments, again specifying the column lists, and then in our values, we have 290, null, 201, and 1700. So we're trying to pass in a null on department name. If you were paying attention a minute ago when we looked at the constraints, you probably know in advance what's going to happen, and sure enough we get an ORA 1400 error that we cannot insert a null into that table. That's because we have a constraint there, of course. So why don't I change that null value to new department, and I'm actually now going to test this by taking this 201, which refers to a manager ID, and I'm going to intentionally put a value that I know does not exist in the related table employees. I know this is an academic exercise, but this is what building a solid relational database is all about. Here we get ORA error 2291, integrity constraint violated, parent key not found. So what that means is Oracle consulted the related table, the one side of the relationship, employees, verified that there's a 2201, there's actually not, so we raised the error. If we make that 201 instead of 2201, run the statement again, tells us one row is inserted. So of course we can verify that again easily enough by editing our earlier select, and there it is. Another variation on a theme occurs on line 19. Insert into departments, no column list specified, but we're just specifying values. 230, research, 145, and 1700. Now should this work? Let's test it and see. Actually, let's change the value to something we know will be unused. One row inserted, so it liked that just fine. Again, it's all about ordering. That is to say, if we tried this, let me make a 310. I'll change the department name to 310 department. I'm going to shift the order here and put manager ID before the department name, and then finally the location. Let's see what happens here. ORA 1722, invalid number. Now you might be wondering, well, what if we put the column list here in parentheses, like so. Although the column IDs are out of order, department ID, manager ID, department name, and location ID, that's different from the column ID order that's in the base table. The labels do in fact match with our data. Let's see if this works. Let me change this value again. Well, no, we'll leave that alone. Select this. One row inserted. Verify, and there it is. Nonetheless, friends, I would be careful with that. That is to say, adding your values in an order other than the column order that's in the tables. As I've just demonstrated, as long as you have a one-to-one relationship in between your column lists and your values, it looks like Oracle accepts that just fine. But again, I'm very much, when I err, it's on the side of being careful and being explicit, so just consider that. Next example, we're inserting into departments. I'm going to add, in this case, we're specifying 320 research and 1700, so we have a missing manager ID here. Of course, you can expect what the problem is going to be. It's an ORA 947 error, not enough values. By the way, every error condition that Oracle is aware of is affixed to a unique ORA ID. There are sources online in the Oracle documentation and elsewhere that can give you a really nice lookup and insight into what these particular ORA errors mean. Just wanted to say that because we're seeing a lot of them here. Our final example of the insert statement is the embedded subquery approach that we looked at in the whiteboard portion of this nugget. Here we're inserting into a table I've created called department new. Now, the point with this is I want to take some data from the departments table table with which we've been working thus far, and I want to copy it into a new table. So what I've done, note that I haven't recreated all 4 of these columns. I've just recreated, it looks like 3 of them: department ID, department name, and location ID. We're leaving out manager ID in this department new table. I also want you to understand that I've analyzed the data types in the departments table and made sure to mirror those such that department ID is a number 4, department name is a varchar 230, and location ID is a number 4 as well. Nullability is disabled on the first 2 columns and enabled for location ID. So given that setup, let's come back to our script window and see what's going on. We're going to insert into department new the contents of an embedded select statement. Remember, we don't need the values clause when we do this, and the select statement is constructed exactly the same way that we build selects anyway. So I'm going to select star from, so I'm going to select department ID, department name, and location ID, which neatly lines up with my 3 new columns in the department new table from departments. And I'm not doing any row filtering with where. I'm going to grab all of the values. 31 rows inserted. So now, of course, I can test by running a select splat from department new, and there you have it. Really good tip to know if you need to copy data from one table into another. Now, without any further ado, let's transition into the update statement, which means, of course, we're editing data that exists in a table. Let's run a describe on the employees table just to verify what's there. Describe doesn't give much information here, actually. SQL Developer gives us a tremendous amount of flexibility with metadata, doesn't it? So let's select employees and visit the columns table. A lot going on here in terms of column names and data types. This is perhaps the biggest table in the HR schema. We can visit the data tab to see what's actually in the table data-wise, etc. Let's come back to our demo script. In this first example on line 39, we're updating the employees table, and this is the last name example that I gave earlier. We're going to set the last name to Stewart where the last name is Greenberg. So if we come back to our employees data list, we see that employee ID 108's name is Nancy Greenberg. Of course, before making this update, we'll want to be reasonably sure, if not certain, that there exists only one Greenberg in the table. To that end, you'll note that I have a comment that instead of having our where clause focus on the last name, we might want to try employee ID 108 in our where clause instead. But no matter, let me run this query, and then we'll run a select star from employees where employee ID equals 108, just to verify that that update did in fact go into effect. Yes, sure enough, now Nancy Greenberg is Nancy Stewart. Our next example on line 47 shows us how we can set the values of more than one column at once. In this case, we're changing the phone number to this and the hire date to 22 May 2011 for employee ID 100. Now, who is employee ID 100? Of course, we can just run a select to see. It looks like it's Stephen King, and let's verify right now that his number is not what we're going to change it to. It looks like right now it's 1, 2, 3, 4, 5, 6, 7, and his hire date is actually 17th of June 2003. So those were the previous values. We'll run the update statement and now pull back employee ID 100 from the table, and his phone number has been changed, his hire date has been updated. Now, you know, if I were to just cut this connection, that is to say close my HR connection to the database, Oracle will in fact commit all of these changes or make them permanent in the database. And the reason for that is that the Oracle folks built into this tool, SQL Developer, implicit commit mechanism. Now we're going to discuss transactions and the commit process in the next nugget. I'm just giving you a little bit of an introduction or warm up right here. But the reason why it's important to think of committing when you're making any kind of DML change to your data is that unless you do either a formal commit statement, which I'll actually do right now to make those changes permanent, I'll just type commit and then run the statement, and it tells us here committed, that if, for instance, you're in the SQL Plus tool and you just use the Windows close button to disconnect, you're going to lose any changes to your data that have not been committed. Some applications issue an implicit commit. SQL Developer does because that's how it was developed. SQL Plus doesn't if you hit the X key. or the X button, I should say. And that's just something that we'll revisit in the next nugget for sure. Final example for update, very simple. It shows us how to invoke or use a function with the statement. In this case, we're updating the employees using set with no where clause. Now you'll recall from our whiteboard portion, the theory section of this nugget, if we don't specify a where clause, then this change is going to be global to the entire table. Now once again, what is the deal with email? Why are we invoking the lower function? Well, just for academic reasons, of course. The way email is stored in the source table is all in uppercase. You may have a business reason to convert that to explicitly lowercase. Maybe it's just a formatting issue. So I just am giving you this here as a good example on how we can in fact invoke Oracle functions in our update statements. Remember, functions are the workhorses of our code modules. So let's select this, run it, tells us 107 rows were updated. So we can verify by running a select email from employees. And now they are all in lowercase. There it is. Manipulating data part 1 of 2 review. We started this nugget by making sure we fully understand what the major DML or data manipulation language commands are, and we contrasted those with the other command types. We know about DDL, DCL, and TCL in specific. In this bookend nugget, we're going to continue this discussion in the next one. We covered 2 of the major DMLs. We now know how to use insert to add new row data to a table, and we also know how to update or change values that reside in a previously created table. Really good stuff here. These skills are ones that you'll be using every day as database administrators. I hope that this has been informative for you, and I'd like to thank you for viewing.